Hey guys, it's Dr. McJunkin. Happy Friday. We're going to be jumping into our last lesson for week 3 of online learning. This will be lesson 6. We're going to be talking about dependent events, probabilities. We saw independent events last time, and we'll review that a little bit at the beginning here. And then we're going to have dependent events as our topic for today. So we're going to be looking at board games. I love board games. Everyone loves board games. So we're going to be playing some board games and some dice games and some card games in order to talk about these probabilities in a real life scenario. So before we get to dependent events, let's just review independent events. So for these warm-up examples, the first one I want to figure out is what is the probability that I roll a 5 if I'm rolling just a single die in a board game. So I want to get at least a 5 in order to win the game. Maybe there's some kind of game where I need to get exactly a 5 to win. What's the probability that I roll a 5 given that I'm rolling one single die? Well, the probability that I roll a 5, let's see, how many 5s are there on the die? Well, there's only the one 5 on the die. So there's only one way of getting the thing that I want when I roll the die, but there are 6 total sides. So the probability that I roll a 5 then is 1 out of 6 because there's one 5 that I want out of 6 total options. So pretty easy, just probability of rolling a 5 is 1 out of 6. Reviewing again from OR and union probabilities, what's the probability I roll a 5 or a 6? Well, that's the probability of 5 or 6. That's the probability of 5 plus the probability I roll a 6 minus the probability I roll a 5 and a 6. However, I'm only rolling one die still, so I can't get both a 5 and a 6 at the same time. I either get a 5 or a 6 using one die. So these are mutually exclusive events, so I don't get any overlap here. So I really just need the probability of rolling a 5 plus the probability of rolling a 6. I already have the probability of rolling a 5 from above, that's 1 out of 6, plus the probability of rolling a 6, well, that's also 1 out of 6. There's one 6 on the die, there's 6 total 6 total numbers on the die. So that's 2 6 or 1/3 to get those, either a 5 or a 6. Should be pretty simple. Okay, from last time, we're rolling a die twice now. Now we're rolling the same die 2 times. What's the probability that I roll a 5 first and then I roll a 6 second? I have the same die that I'm rolling twice, but each roll is independent of each other. So this is independent events. So if I want to roll a 5 and then a 6, well, that's just the probability of rolling a 5 times the probability of rolling a 6. Because these are independent events, I can just multiply the probabilities like this, and they do not matter. Probability of 5 we saw before was 1/6. Probability of 6 we also saw before is 1/6. This is 1 out of 36. So we've seen those things before. Remember that these are called independent events. So these are examples of two events in the exact interval are independent events. Okay, so these are independent events because the first roll, rolling a 5, does not change the probability of rolling a 6. It's still a 1/6 chance of rolling a 6 after rolling a 5 the first time. What if the events are not independent? So let's go ahead and look at some of these examples here on the next page. Up here, if you need to pause the video and write some of these things down, this is just reminding people or telling people if you don't play cards, what a deck of cards is made up out of. So different types of cards, 52 total, 4 different suits. 2 suits are red, diamonds and hearts. 2 suits are black, spades and clubs. 13 ranks in each suit, so 2 through ace. And then there are 26 red cards and 26 black cards. Okay, so if you need to review that or look over those, that will be helpful. There's also this sheet of cards in that I'll repost it for this example or for this lesson. So for this example for dependent events, I'm going to bet my friend that I can draw 2 black cards in a row from the deck. So when I say in a row, that means I'm not replacing the cards. So I'm not replacing the cards. I'm going to draw a card off the top. I'm going to see what it is and put it to the side. And then I'm going to draw a card, the next card off the top of the deck as well, and see what the probability is. So I'm not putting that first card back. I'm drawing it into a hand or putting it off to the side. Then I'm drawing a second card. And I want them both to be black. So what's the chances that the first card is a black card? So what's the probability that the first card is a black card? I'll say probability of B. Well, if we don't know, we can look back up here. There are 26 black cards out of 52 total cards in the deck. Half and half. So the probability that I get a black card is 1/2, 50%. That I get a black card for the first card. Okay, so that's the easy part. Now the new stuff. What are the chances that the second card is a black card? So I want the second card now to be a black card, and I'm not putting that card back in, I'm not shuffling it back in. So after I draw the first black cards, how many black cards are left? Well, there were 26, but I already drew one, so there are 25 left. So there are 25 black cards left. Cool? After drawing the first black cards, how many total cards are left in the deck? So this was black cards. How many total cards? There were 52, but I drew one. So there's only 51 left over. There's only 51 left. So then putting these together, what's the probability that I draw a second black card? So the probability the second black card, or the second card is black. Well, there are 25 options left out of 51 total cards in the deck. It is not 1/2 again. The probability of getting a second black card is no longer 1/2 because there are less black cards now, but there are also less cards in the deck. This is not 1/2. 25 over 51 is not 1/2. So if I want to say the probability of the first black card is 1/2, the probability of the second black card is 2/5, or sorry, 25 over 51. What are the chances that I pull 2 black cards in a row? I still am going to multiply these probabilities. So black card, then black card. But instead of multiplying 1/2 times 1/2 like I would have tried to do for independent events, now this first card being gone means that my second probability is not 1/2, but 25 over 51, which is 25 over 102. So this is the key difference here, is that instead of doing 1/2 times 1/2, like I was putting the cards back or they didn't affect each other, the second probability is affected by the first one. So these are called dependent events. These are called dependent events. When I'm looking at 2 cards, they're dependent events here because I'm not replacing that card. The key word here is that I'm not replacing it. And when I take the first card out, it's gone forever, and that changes my probability. The big thing that we'll always see here is we always see the denominator change. So we're going to always see the denominator change here because we're drawing cards, we're drawing marbles, and we're not putting them back. So we always see the denominator change because there are less objects to choose from. If not replacing. So we're going to always see that denominator change. We reduced the 26 over 52, the initial probability, to 1/2, but the initial denominator was 52, and now the second denominator was 51. So this 1/2 was actually 26 over 52. So we saw the denominator change from 52 to 51 because there were less cards. The numerator also changed because we were drawing black cards and we had the less black card, but the numerator does not always have to change or be affected if we're looking at different colors and things. But the denominator will always change. Okay, let's see a couple more examples so we can see this a little better. Okay, let's line this up here. Great. So imagine I have a bag of 2 red dice, 3 green dice, and 1 blue dice. So in total, I have 6 total dice. What's the probability of drawing a green die and then a red die without replacing the die in the bag? So again, we're taking something out and we're not putting it back in. So the probability that I get, let's see, a green die first. Well, there are 3 green die out of 6 total die in the deck. So it's a 1/2 chance there. The probability of getting a red one after getting the green one, so I'm not replacing the green one, is, well, there's 2 red die. But now my denominator has to change. It's going down by 1, because if I got rid of one of these green die, there are only 2 left now. So there's 2, 4, 5 total die left over. So if I wanted the probability of green, then red, I get 3 out of 6 times 2 out of 5. Let's see, that's 6 over 30, which reduces to 1/5, or a 20% chance. Notice again here that the denominator changes from the first one to the second one. We should always see that happening. If we don't, we know that we're doing something incorrect. 2 last examples looking at these cards. I'm sorry I didn't print out them in color because it does revolve around their colors. So let me go ahead and actually take my colored pens here and show us which ones are red versus which ones are black, because that will be helpful to us in these problems. So I got 4 black cards and 3 red cards, and I'm going to only assume I have these 7 cards for these exercises. So for the first one, what is the probability that you draw a red card and then draw a black card? Well, let's do the red card first. There are 1, 2, 3 of them. So there's 3 red cards out of 1, 2, 3, 4, 5, 6, 7 total. So the probability of a red card first is that. The probability of a black card after drawing the red one. So assume that maybe like the King of Hearts is gone. Assume the King of Hearts is gone. The probability of black card, there's still 1, 2, 3, 4 black cards left because I didn't get rid of any of them. But because I got rid of one of the cards, there's only 6 cards left out of the total. Again, we see the denominator change from 7 to 6. So red, then black, is 3/7 times 4/6, which I'm going to go ahead and reduce to 2/7. Cool. So we reduce there to 2/7. Okay, so what I want you to do then is to work on question number 3 by yourself. We're going to reset all the cards now. So we said that the King of Hearts was Hearts was gone. Assume you have all the cards now again. Sorry, you can't see what I'm writing up there. Assume we have all the cards again. So we have all 7 cards that have been reset. What's the probability that you draw specifically the Ace of Spades first, and then that you draw a red card, again without replacing? When I say draw here, I'm always meaning without replacing, because you're drawing it to put into a hand or something like that. So take a minute, pause the video, do number 3, see what you get. Okay, so let's go ahead and look at number 3, see if you got the right answer. The probability that you get the Ace of Spades, there's only one of them, it's right here. There's only one of them, so there's a 1 out of 7 chance you get the Ace of Spades at the beginning. Then we want the probability that I draw a red card afterwards. The Ace of Spades is a black card, so it doesn't reduce the number of red cards I have. I have 1, 2, 3, because remember we put the king back. So 3 out of how many total cards? Well, this card is gone. So 1, 2, 3, 4, 5, 6. Again, our denominator goes down. So then the probability of the Ace of Spades, then red card is just the multiplication. 1/7 times 3/6. and that is 1 over 14. Okay, so if you need to, rewatch the video, pause it whenever you need to take notes and do the example problem like we just did. If you have any questions, I'll be online from 9:30 to 11:30 today. I'll also be on office hours from 2:45 to 3:45. So I hope to see you there. If I don't, have a good weekend, and I'll see you next Wednesday for our 4th week of online pre-calculus. Have a good one, guys. Bye.